I am super excited. I want to wrap up this wonderful conference with something unexpected. So when I was doing my research, of course, I saw the earlier UV talk. I saw the other wonderful inspirations. And I also came across this post on Reddit. This is actually a quite nice article that ended up becoming one of my research materials. Python dependency management is a dumpster fire, lack of better terms. So hello everyone, my name is Keming. I am an AI application developer for a Google partner called Botcopy. We make chat agents for state and local governments. I'm also a student at Ohio State, so finishing my degree in May 2027. I am very involved in the Python open source community, and I basically have a lot of really cool stories to share with you guys today. So if you're just coming in, you didn't miss anything, we are just getting started on the dumpster fire. So let's get started. I realize I need another pair of hands. So this is the right talk. You're at Beyond Benchmarks, a Python dependency management story. I can't fit all those onto one line. So first of all, quick survey. And keep your hands raised because I really want to see, even with our attendees. How many here UV is your main? Like, it's the best thing ever. Okay, keep your hands raised. How many here are poetry main? Yep, keep those raised. How many here are for Conda? You do some research, data science, pip. Yeah, okay. How many here? Keep raising your hand if you manage to talk your boss into letting you use what you love. I can see some maybe contracting or academic work here. It's really living the dream, but that is the problem. Python dependency management is much more complex than whichever you love, whichever you have a personal connection to, and whichever that from the pure tech spec perspective is the best. And we are going to unpeel this layer by layer today to see what actually makes sense when we are choosing what dependency management we use for our own projects, for our business, and for arguing with others about which one is actually the best. The latter one, I think I'm most interested in. So my journey, I pretty much hit all the points that I'm going to cover today since 2016. I was in high school. I was introduced to Conda at my mother's university, where they were teaching that primarily because they were doing research. Introduced to pip. My supervisor was, Keming, why are you installing these Conda dependencies? We were doing a very lean ML startup. So that was when I got introduced to pip and properly setting up my own requirements.txt. Fast forward to 2020, I was in OSU. I was involved in another research group. They're also using pip. After coming out of research, I started taking on a more industry-focused route. So diving into full stack development, 2024, started using poetry at the time for my Ohio project, and then really got into the Python open source community, and right now doing a bunch of open source work using UV. UV is the best. I'm sorry. Now, after doing some research, I kind of feel bad for all the Pixie and PDM folks that are not present today. I will, in the end, make a statement to also recognize you guys. So, since we're saying beyond the benchmarks, let's actually get to the benchmarks. I want to provide clarification that when it comes to researching for a talk to share with others, given the kind of person I read research paper for fun, I want this source to be most up to date, not a one-time someone running some script and got some answers and share on social media. So for the benchmark section of this talk, let's actually look at the Lincoln Loop Python Package Manager Shootout benchmark that just got deployed earlier today. And so Lincoln Loop took a very thorough approach to benchmarking. I just realized this is very small. PDM with UV, pip tools, oops. Poetry, why does it keep doing that? And finally, UV. There are 2 bars for each dependency type. The one on the left is what's called code cache, where you don't really have any package pre-cached when you run the install command. And on the right is when you do have them cached, and you're just pulling the code from your cache. Across the board, on both code cache and warm cache categories, we consistently see UV takes the lead, followed by poetry, followed by good old pip. Same for the time you use to generate a log file. I have no idea why PDM is acting out that way. Same for updates. Again, very consistent pattern of UV taking the lead, followed by poetry, followed by pip. Add package. Same pattern. Tooling, it's an interesting category that I didn't even thought of, given how one-time this. So for those who couldn't see, tooling is the time it takes to install either UV, poetry, or pip according to the official documentation onto your own system. This shows that somehow poetry is taking a little bit longer, but the y-axis are in seconds. So you do this once. Oh wait, you do this every CI when you spin up your staging environment. Okay, that could definitely be a differentiator. And this is it. I think we're forgetting someone. We forgot Conda. I am so sorry. I do admit, I'll come back to this. I do admit that there is a clear difference in needs and focus from developers who benchmark these tools versus the data scientists that actually, flocks to Conda for its data science support. Since the Lincoln Loop repo is MIT license, I will make that one of my to-dos because I really want to see consistent Conda benchmark results, and not just, one-off. Someone wrote a paper, and it's published in 2016. A detail that I'm going to come back to is if we actually look at the Lincoln Loop report. This is a GitHub pages publishing. They are running a benchmark right now. So they run one benchmark, I believe, every 6 hours. And then they average of the last 4 benchmark results, and they automatically build and publish to the world. And they are still actively maintaining the repository. So this is, as a side note, extremely important for finding not just primary source, but reliable, up-to-date, well-maintained primary sources. I wonder if that's going to be the theme of our presentation. So, what about the adoption rates? We know UV is the best, followed by poetry, followed by pip. I don't know where Conda is. Are people actually using these really good tools? Just a quick kind of a survey question to the audience. In terms of like millions, billions, tens of thousands, whichever unit, how many Python repositories, public repositories, are currently on GitHub? Take a guess. $22 million. Given that UV is the best, take another guess. How many of them are managed by UV? How many are managed by poetry? By Conda? By pip? All of them are by pip? Let's see. So it actually becomes a small challenge to identify which repositories are managed by which dependency manager. The most consistent way is to look at the log files. If it's managed by UV, it has a uv.log. Managed by poetry, it has a poetry.log. If it's managed by Conda, it has a something.yaml. I forgot. I'm so sorry, Conda community. If it's managed by pip, as a process of elimination, we will assume it's requirements.txt. Again, apologies to the Pixie and PDM community. I really have to scope down such that this talk doesn't become 45 minutes. I only have 30 minutes. I will definitely come back in the future and continue to improve on the benchmarks. Surprise! Out of 22 million Python repository public on GitHub, the combined is less than 5%. Pip, still a lot. We found 560K requirements.txt files. We found 40K poetry.log, almost 19K Conda configuration.yaml, and emerging, we have UV at the very last, 14K with uv.log. And I don't think all the rest are managed by pip+pyenv or hatch. So I'm gonna say 95+% are just without tooling. This data is generated yesterday and only queried all the public GitHub repository through the GitHub CLI. You can read more on the methodologies and exact results here. So anytime you take a photo of this presentation, you will have the presentation repository. It has a really nice README. I worked really hard on it. So I was really surprised when I found out about this. Let's take a sidetrack. Why must I start without tooling? Let's think about this. Public repositories, Python, the most popular language on GitHub. and tooling, specifically dependency management. There's actually 3 distinct ecosystems that contribute to this. First is that however long ago this might be, remember the last time you ever see a Python tutorial. It tells you complete tutorial from scratch. Tells you to install Python. If it's nice enough, it will tell you to install pip+pyenv. And then you just start by learning the Python native modules. And there's a lot of them. 238 to be exact. I double counted this number yesterday. That was kind of fun. Given Python is so popular across industries, especially in academia, people are using it for scripting, for automation. Jupyter Notebooks, that's a huge one. As a default startup project, learning tutorial for assignments, and just using the standard library, sometimes even without defining a version, because we don't need production quality for college homework. This is actually the majority. And it explains. However, there's also the downside of, are we sure that all of our academic research results are reproducible? I dive a little deeper on that in the documentation. And then, of course, we cannot see private repositories, where I'm going to assume are well managed. Okay, so everyone should just start using UV, right? We have to be careful, though. I know I'm in love with UV. UV offers GitHub Actions, Docker images, Docker-based images. UV offers migration guides from across the spectrum. And UV is very well maintained with a extremely efficient, Rust at its core. But what's next after UV? Are we just going to keep repeating pattern? And we can see that, poetry is already gaining traction according to the poetry.log file percentage, and UV is just getting started. We have to think about switching cost. This talk is beyond technical. It also takes both personal preference, industry inertia, and business value generation into consideration. Let's start with the simplest. For a beginner, there's no cost. You're learning a new dependency management. You probably have used 1 or 2 before, just like me back in 2020. Everything is fresh, and you're actually expanding your knowledge of the Python community, industry, by learning something new. What about data scientists? What about our researchers? Now, earlier I mentioned Conda is quite closely coupled with the research community. A lot of times, I have to double check, is the same Conda package available on pip, which is what non-Conda dependency management systems fetch package from. Again, as a researcher, focus is not on writing code, but more on producing high-quality research results. And you're starting to see team interactions. You're no longer just working alone. You can no longer just discard something and expect everyone else to kind of read your mind. It gets worse. If I'm writing Python code instead of Node, instead of JavaScript at my work, this is what I'm going to start considering. The migration is simple, but you have to take into consideration, okay, how does this fit into my feature development timeline? What about infrastructure? IDE updates are pretty simple. Local development setups are really simple. But it's taking time off of critical bug fixes, client meetings, planning and grooming. Gets even worse for engineering managers. Now, instead of a team of 2 or 3 colleagues as a developer, it's 10 plus developers and perhaps even entire departments. Everything has to be moving in unison. And finally, open source maintainers. The Python community is pretty fragmented. It's not inherently a bad thing, just that it's so vast that we don't want to further create complications to drive people away from it. If we started something, we stick to it. So it's really, the root problem is not which one is the best, but the community is inherently fragmented, and we need reliable dev automation to effectively manage these new, not only tools, but new knowledge. So let's see. We have AI. We have the documentation. We want something that's fast, that's simple, and it's probably not. Oh wait, I thought I have 7 more minutes. Okay. How many here uses AI in day-to-day job? Raise your hand. Perfect. How many here knows what an MCP server is? How many here gets hallucinated outputs from your AI usage? Yes, I was migrating from Poetry 1 to Poetry 2, and the AI just wouldn't budge. So, has to be highly customizable. Let's see a demo. What if we can leverage the same automated workflow so it's as simple as possible for the developer to maintain? It completely relates all the tasks to the AI, and we have the most up-to-date documentation, just like similar to what LinkedIn Loop did. Welcome to the Python Dependency Manager Companion MCP server. This is something I built that has the latest doc from pip, Poetry, UV, and Conda with auto updates. Let's see what the latest build is. So we can see yesterday, it published a latest version pulling automatically all the official docs. And now the new image is up on Docker Hub. Instructions are extremely simple. We pull the image, and we shove it into our MCP server config. It's local, and it runs on Rust because it uses tend2v, the Python binding, which is Rust-based, for not semantic search, full text search with fuzzy matching. Let's ask a question. Give me a comprehensive comparison between pip, poetry, conda, and UV. Why is it searching the web? Oh, I need to turn on the server. I'm skipping a lot of steps, but the README should guide you. Here I'm doing something magical. Usually what MCP server does is that it's kind of a two-way communication between the tool and the AI. There's no user involvement, but something magical is happening. Somehow, I'm getting these nice reports. This is the power of tool prompting. Is my tool is actually helping the AI give more structured and focused answer with reference to official documentation. It's no longer just grabbing the answer. The tool is making the AI smarter. It's still going. Yeah, look at that. Let's try clicking on one of the links. That's the official UV GitHub repo and the docs page. Why stop at Python documentation? Any documentation. I'm actually building one of the, for Dialogflow CX, public documentation in my work. And if you want to use this as template, here's the code for it. Thank you so much.